Hey, so in the last video we set up Kubernetes and we deployed traffic and we deployed our first OpenFlow, and the next thing we might want to do, there are many things we can do, but one of the things that we might want to do is set up reporting. So there are two things that's relevant here. One is that we probably want to be able to collect metrics and spans around the platform and the components around the platform, so we can see how they're performing, we can find bottlenecks, we can monitor for issues, quickly scale up and down whenever needed. But we also want to be able to create report and dashboards based on the data that you are collecting or is flowing through the platform as part of what you are using it for. For both of those, we use Grafana. You don't have to, you can use whatever you want. You have directly access to the database and could set up Tableau, Jet reports, MongoDB, Graph, Power BI. There are lots of solutions. But when you are adding data to the platform, all data will have an access control list, and we use that for securing the data. So if you use the Grafana connector for doing report and dashboards on the data in the database, because you are signing into Grafana with a OpenFlow user, we can then filter the data that you see in the reports based on the user you are. So you no longer have to design reports where you have to remember to remove sensitive things or create multiple reports depending on the person watching it. You simply just create the report, and whatever the user has access to, that is what shows up inside the report. For the other part, we use OpenTelemetry for collecting, rather for exposing the metric and span information, and the OpenTelemetry exporter can then expose or send that data to other platforms. For metrics, we made it easy to set up either Victoria metrics or Prometheus. In this case I chose Victoria, but Prometheus can also be used. And the beauty about Victoria metrics and Prometheus is that they are both supported directly inside Grafana. So when we go in and enable Grafana, we can also tell it to create two data sources that is pre-configured for that. So the first is the OpenFlow data source, the one that allows pulling data out of the OpenFlow database, and the other one is the built-in Prometheus data source that is then configured to point to either Victoria or Prometheus depending on what you chose to use. Let's start by looking at the OpenFlow data source. So we enable Grafana, and as you can see, we don't have it yet. So if we update the configuration, and remember to save, that might help. There we go. So now it's fetching the image. This is an image with a relatively new Grafana, and it's preloaded with my data source for connecting to OpenFlow. It will then inject some environment variables so it knows how to handle authentication, which you will see in a second. So if I now go to the browser and try and access Grafana, you will see that I get an error message telling me that the client ID is incorrect. It doesn't know who I am or who the application that is requesting authentication is. So when you log into OpenFlow, you have providers. Providers is a way for you to add different ways that people can sign into OpenFlow. So that could be Office 365, a local ADFS server, OAuth 0, Google app, LinkedIn, Facebook, whatever you might think is interesting. But OpenFlow is also an identity provider. It also allows other applications to use OpenFlow as a way of authorization and authenticating people, and that's what we do with Grafana. So if we go into OAuth client and add a new client and call it Grafana, this, using the defaults, will use the right way of exposing this as an OAuth 2 client and not a pure OpenID Connect client, which is what Grafana wants. So once that is added, if everything went well, I should now be able to sign in when I'm trying to access Grafana. And I just tested this before, so I probably have an old cookie. Yeah, sorry about that. So that didn't go too well. And the reason is that when you add a new client, it will update the list of known clients so that the application works and so Grafana can validate the tokens. But because we're using 3 API nodes, the 2 others didn't know that it caches that and refreshes once in a while. So after restarting all 3 APIs, it of course started working. So sorry about that. So if I now go to, let me show you. So if I go to Grafana, it prompts me to sign in. And once I sign in, I now have my Grafana. And it is pre-configured with the 2 data sources that we talked about. So just to give you an idea, so if you want to create a report on something, using the OpenFlow, there is a relatively crude designer that allows you to start querying data inside the database using MongoDB queries. You're building a aggregation pipeline here that is automatically grouped by the group parameters that you set here. But if that doesn't fit your need, you can always watch the current aggregation and you can then modify it to fit whatever needs you have. But it does make it relatively easy to go in and quickly create a report on something. So let's say that I'm interested in knowing how many users that has been created lately. So if I create a new dashboard and I go to the users collection, I can go in and watch the number of new users created the last 2 days or last 7 days or whatever. Maybe I want to know how many people have signed in, then this is the number of sign-ins the last 7 days, and as you can see, you can easily drill down and watch very specific time frames. Is that what you want? But this works on any data. So any custom data that you could upload, you can either create timelines, which it's very good at, so time series data, but you can also create reports about anything that you would want. The other part of Grafana is the ability to watch the performance of the platform. So if we enable the Open Telemetry exporter, if you have remote node-REDs or if you have robots that don't have or if you have robots and you want to send telemetry data for those, you have to expose it. But for now, we are just interested in OpenFlow, and the node-RED started by that OpenFlow, so we don't need to expose it. yeah, let's take this right away. But this will only give us metric data from OpenFlow and from Node-RED, which is of course very interesting. But we usually also want to be able to monitor the entire infrastructure and the entire platform. And since we're running Kubernetes, the way that we can do that is using kube state matrices. So this will deploy 2 extra parts in your kube system namespace that will collect a lot of information and expose it as Prometheus stats, and it will then configure the exporter to collect those information. So this is something that you enable in the OpenFlow instance that you want to be running for yourself, not one that you are using for other customers. This is information you want to keep for yourself. But by enabling these, so enabling the exporter allows collecting data from this OpenFlow, and by enabling these 2, we can also collect for the entire platform. We then need a place to send those metric data, and that could either be Prometheus or Victoria. In this case, I'm going to be using Victoria metrics. So by enabling this, this will this will create a configuration file for the exporter to send this to the Victoria metrics part. So if I did everything correctly, this should now just work. There we go. So as you can see, we now have our Victoria metrics part, and we have our OpenTelemetry collector. And once that is up, I think it's up now. Now I can select Prometheus, and I will be able to collect things like query times from OpenFlow. So for instance, if I'm interested in knowing exactly how long is queries to the database taking, I can simply go in here and get a graph on that. I don't know what I did wrong there. So usually when I help people set this up, I create a couple of reports that contains some of the basic information. So for instance, this will now give us an overview of how MongoDB is performing. I should probably stop the video and give it 5 minutes to collect some data to show. Yeah, I'll do that. Yeah, so it's been 5 minutes or something like that. And as you can see, the data is now slowly coming in. That means we should now also be able to see a little bit of data about how the platform is actually doing. So import. And here is one way of representing some of the metrics around how OpenFlow is performing, how the entire platform is performing right now. So usually when we set this up, we create a namespace per OpenFlow. So usually you focus on one namespace, and you can then go in and say, I just want to know about MongoDB, or you just want to know about Node-RED, or maybe you want to compare MongoDB and the APIs or whatever. And here you can see the CPU and memory consumption of those. One thing to be very aware of is restarts. If something is constantly restarting, a couple of restarts doesn't matter, especially if we're talking Node-RED, but pretty much anything else you don't want to be restarting. So be aware if you have something that is restarting that is not supposed to. It can be hard to catch because usually things recover so fast that you don't really notice. Which is awesome, but you still want to know and you still want to fix it. Also, by default, when something gets deployed to Kubernetes, it uses a fair share model where everyone gets a fair share of the CPU and RAM. And the more you start, the smaller that slice becomes. And that means once you get closer to high memory pressure or CPU pressure, everything will start running really, really bad and start restarting and crashing. That's bad. The way we can control this is by actually restricting and requesting the amount of resources needed. That's, for instance, what we normally do with Node-RED when we're running in multi-tenant mode. But you want to be aware of that, and that's why keep a close eye on the amount of resources that you're using and start scaling up before you hit the limits. Yeah, I'm not going to cover Jaeger and spans in this video. I might cover that in a later video at some point. The last thing that I want to cover is, so Grafana is not a true monitoring platform. That's not really what it's built for. But with Prometheus and with the OpenFlow data source, they are both created as server-side add-ons, which means that they support alert rules. So one thing that we could do is we could pick some kind of graph on something that we are very which is important for us, or has some kind of looking for the right words now. Usually me and others will have a good idea of what is good performance and where does it show that you are now getting close to something that needs to be fixed or looked at. And what we can do inside Grafana is that when you create a graph, you can then go to the alerts tab and you can then define parameters for when you are in alert zone mode or when you are not in alert mode. So creating simple rules like saying we need to see values, so if something dies and stop reporting in, you can react on that. Things like response times of the database, the amount of messages in a queue, the time it takes to process specific workflows, lots of different things that we can monitor, and you can then set up notification rules on those. So you send notifications to a user or to a service, and when you do that, there are different ways of doing that. So you can send emails, you can send Discord messages, you can send Hangout chat messages. You can create webhooks where you simply just call a REST service somewhere and then that brings on the message. I usually use email notifications for the most common things, and then webhooks for more complex scenarios where I then create Node-RED workflows on separate OpenFlow instances that then react on those and handle that. But there's a ton of ways that you can do this. So this is good for the most basic crude monitoring of the system. More in-depth monitoring using Datadog or whatever would probably be relevant once you go into full-blown production. And I wish you good luck.